So today, today on the bench is this thing. I tell you what, this is really difficult to do when your screen's upside down. There we go. A Gemini XGA5000. I brought a job lot of new but used broken Gemini amplifiers. A man turned up the other day with a pallet with them wrapped up on them. This was the one at the top of the pile I decided to start working on. So that is the board that had blown. So it's in here. Normally, got a lovely heatsink compound all in my hand. So normally that heatsink sits there. This board, transistors on the back of it, bolts onto there. That's one channel. That's the other channel. So the destruction mode was interesting. Here's the components I've had to take off. That were fried. So zoom in on this a little, if I can. There we go. Where are you? There you are. Right, so the power resistors this side had burned out. All the power transistors had burned out. The driver transistors, although they were reading on the meter diode checked at least okay, it's pointless trying to reuse them. They took a hit. If they're not dead, they're on the way out, or they're going to go pretty quickly. 100 ohm resistor here, and there's some tiny little SOT23 2N55 51s and 2N5401s form part of the short circuit protection on the output. They took a hit, and yeah, just some diodes and stuff associated with that circuitry. So it's fairly standard circuit in here. So you've got like, there's some tiny SOT23 2N50, what are they, 5501, 5401s in here. They form like the input stage. Standard long tail pair based. Collectors of them are going into basically a push-pull voltage amplifier stage. The output of that's going into your standard. It used to be quite common on amplifiers. You'd have instead of a constant current sink on like a single, or a constant current source on a single voltage amplifier stage, you'd have like long tail pair based voltage amplifier stage. It would feed into a differential current source sink. One of those would be tied base to collector, basically be tied together. They'd be sharing same value emitter resistors. It flip flops the current between them, but the overall total current remains the same. So yeah, well, there are some adjustments on here for DC offset and bias. And you'd imagine they must have been done. So when someone's turned it on, maybe they've shorted it out, or it's a blob of solder or something's found its way around onto somewhere, or they're just some shitty transistors, and when you actually try and first load them up they break, who knows. But output stage, one of the transistors in the output stage, one side shorted. That's then caused the feedback loop to try and compensate, turning the other side on. Burned out, burned out, burned out. That's gone back to the driver transistors. At the same time it's fed into the protection circuitry. These 100 ohm resistors here are they go from it's a standard emitter follower, so they go from the base side of the output transistor drive down to the actual output rail there to turn the output transistors off at higher frequencies. That's why they're quite low value. So yeah, one side or the other had to take a hit first, and the reason it had to take a hit first is because there's no rail fuses in this. There is one fuse, and it's in the IC plug back at the back of the amplifier, just there. That's the only fuse on it. There is no in the power supply. If we zoom out, that way on. So yeah, there's no fuses at all. None of these, nothing, not a primary side fuse, nothing actually in the chassis. It's just the one fuse there. So when that module shorted, instead of just blowing the fuses, you know, it might have just ended up blowing one transistor, and the fuses could have blown. But it's shorted, all the transistors are shorted, and there's just been a direct short current then until the resistors on one side burn out. One would have gone first, then all the current would have had to go for the other, so it would have burned out, but these are probably pretty shafted too. I've got a low coming, I'll change them. Oh, so yeah, that's the amp board. So this is the 5000 series. I actually have some of the 5s, some of the 4s, some of the 3s and some of the 2s. I've not even took the lids off the other ones yet. Like I say, this one yesterday I took it apart, did a bit of reverse engineering on here. There's some stuff in the middle of this board here which is, like, from what I can ascertain, I've not reverse engineered it yet. It's something to do with the fan control, because there's 4 bloody fans in this thing. 1, 2, 3, 4. They make a noise, and there's a diode here which is this diode, and it's got nothing to do with the bias tracking. That's the bias transistor. So this appears to link across into this middle bit here, so I think that's something to do with temperature control for the fans, and there's a 105° C switch which operates the protection circuit if it trips. So yeah, this channel's working alright, it's fine. So I shall fix that up. I shall go a bit more detailing through soldering and stuff when I actually build this up, but transistors that were taken out of it are, so they're TO, is this a TO247? I think that's TO247 case, isn't it? You got in this package, you've got like the early ones, the smaller ones with like the metal tab sort of round it, is a TO3P. I think this is a TO247, and then the TO264. Now this might be a TO264, and then there's a TO247. There's like a bigger one, pretty standard. So there's some Toshiba TTC5200s one side, and TTA 1943 the other, and good old fashioned 2SC2073s and 2SA940 driver transistors, and like I said, there's some SOT23 size 2N54 and 2N55 small signal stages. Interesting, the board's marked for different transistors than what's actually come out. The board is marked for 2SC5198s and 2SA1941s for the output stage, and 2SC4793s and 2SA1837s for the drivers. But there are a few things here. Now, I know this thing's going to be relying very, very heavily on rail collapse. Small capacitors, what are they? So 6,800. Now, it says, if you noticed, on the cover here, it says, optimistically, 5,000 watts, what my ass, right? Even if we was to say, replace this rather inefficient toroidal with a high efficiency power factor corrected switch mode supply, you can get like 95% power factor. Well, 0.95, it's over 1. 0.95 power factor, 5 kilowatts is still more than you can draw from a single phase 13 amp UK plug. And if we say we was being real generous and letting this have, say, a power factor of 0.8, which it just couldn't achieve, but let's say it was, we'd need the equivalent of the current needed for 6 kilowatts from the plug. So yeah, now 75 volt rails relying on some power supply collapse under load, they're probably dipping, well, they need to be dipping, because double pair of output transistors, so just basically 2 for one side, 2 for the other, 50 volt rails, realistically working hard into 4 ohms, that's fine. 75 volts into 8 ohms, fine. So these need to be dropping down really to, like I say, if they're under heavy load, they want to be dropping down to the 50 volt mark. Reckons it's bridgeable into 8 ohm. Again, if it was 16 ohm, 75 volt rails on 8 ohms should give you easily 350 watts or so. 75 volt rails on 4 ohms, you'd be pulling sort of 500, you'd imagine. Realistic terms, you know, start taking into power supply collapse and stuff. Yeah, so I ain't got a calculator for it, I can't be asked to do the maths properly. Just off the top of my head, figure somewhere around that mark. Bridged, 75 volt rails into 8 ohm. If you had a big enough power supply, like a real beast of a power supply, and you should realistically see 1,000 watts. But this transformer, I'm going to guess, looks about 500 VA maybe. I'm going to say bridge into 8 ohm. It might push about 500 watts. Really, because you can overload a toroidal transformer quite happily. But I'd say realistically, it's going to, if you're really pushing it that hard constantly, I don't think these output transistors are going to last long. I'd want to see at least 3. I would say when this is up and running, 8 ohm each channel. If you're going to bridge it, 16 ohm. So that's this one. There's another one. It was made me chuckle today. I'll just pick it up off the floor here a second. So this is also an XGA5000. Now this happened to be, out of all the ones I was unboxing today and just like plugging in, this happened to be the last one left. Take it out of the box, and this was all like so. That's about, you know, there was like a screw in the corner here and one here. Wrong screws as well. Upon taking those 2 screws out, this side flung up to like that side's like that, and you can see there's this big crease here. Well, the reason there's a big crease there is because whoever was trying to take this apart with Dave's fucking DeWalt hammer drill from his van, for whatever reason, hadn't been able to get these 2 screws out. It just so happens they sat opposite each other on here, and this is how much they've manked them up trying to get them out. Yeah, completely nothing. So, and it just leads me to my question, right? If you don't have enough skill about you to be able to even take the right screws out to take this thing apart, because they've took screws out they didn't have to, and then likewise the screws they tried to put in, like it's one of the fan screws, like a real thick grub screw, they've just tried to ram one, shove one randomly in here and one back there. At what point do you think maybe we shouldn't be messing about this? Maybe, or whatever's inside here is probably above what our level of understanding is. It's that old thing, isn't it? A little knowledge is a dangerous thing. They've got so occupied on. So I know, right, I understand. Yeah, maybe they was having a little party or something. It's been set up for use. You'd imagine it's gone out, because I can't fathom that someone, if this was say a little bedroom DJ setup or they was trying this out in their home, that they'd have destroyed this thing to this level, especially when it's under warranty. It's also the fact that whoever gets it returned clearly doesn't open the box, because they just said, I'm not honouring your warranty, mate. You've clearly been inside the fucking thing. But at what point in the simpleton's mind, I know I sound like I'm being very derogative here, but derision is due sometimes. So at what point, when they couldn't even get the case undone, and did they think, well, I'll tell you what, if we can't get it, we'll just pry it open on each edge. So they pried this edge open, pried that edge open, bent the top of the case. What did they think they was going to get to inside? Did they think that if they've got Dave the fucking Chippy's DeWalt drill in their hand, which had a bit in it that was too small to undo these screws at, when they pried it, they was going to be able to just ram his drill in and start smashing it about? And now, luckily for me, and very luckily for them, they couldn't get any further than getting this case off, because it means they've not messed about with the innards in here, for me, and for them, it means that's probably why they're still fucking alive, because who knows what they'd have actually started trying to do had they been able to get better access. But you make sure, what were they looking for? Were they looking for the big red button that says if amplifier broken, press to fix? So yeah, look, they've undone the fans. The fans, you wouldn't have to be very smart at all to figure out that when you look in the back of this thing, from the back, those fan screws clearly aren't holding the top cover on. And even if you thought, well, maybe the top ones are, why would you undo the bottom ones too? You can clearly see there's a fan. And when you'd undone the first one and it was all rattling around in there, you'd think, oh, hang on a minute, maybe I don't need to undo that. But ultimately, they got the screws that actually hold the case undone. Undone. That was the wrong word, but the screws that needed to come out undone, apart from these two. So, you know. Anyway, so ultimately they've not. The one thing they could have done is try changing the fuse in the back of it, and they've not done that. It's still blown. So comically enough, I've not actually even gotten around to testing this one to any great amount. So comically enough, it might be fine, and they might have just blown the fuse in the back of it. Let's see if we've got any shorted. I don't know. There we are. Shorted output transistors on this side. So yeah, this one's actually blown the rail fuse out. Shorted output transistors on this side too. Right. They have then, the fact both boards have gone, yes, they've bridged something across here, and in the time it's took the output relays to go, it's took the whole lot out, because the chances of two completely separate boards going like that, unless, I was going to say unless they, no, all the anti-tamper stuff's intact. I was just wondering if there's maybe the fact that they had actually got it apart and had put like the innards from some different ever broken ones and what that meant they'd have had to have a stack of these things. And yeah, no, none of the there's all like anti-tamper paint on everything, and none of it's been touched. So yes, this one's actually blown all of the, yeah, look, even base to collector shorts to get the meter in short, it would help. So yeah, if you want to measure if bipolar junction transistors are shorted, if you put your meter on diode check mode and you see that, especially if you put it on like conductivity and you get that, they're knackered. They're knackered. What you should see, working bipolar junction transistor. So this one will still read good as a diode. Just depends if this is the A or the N. I can't read it in this light. Swap your probe leads around. So a P-type one, if you put your negative probe on the base terminal, like this, when you probe the collector, so you'll see basically a diode like reading 627 ohms. You'll see, so yeah, base, you'll see that shorted is shorted. It's they're dead. So this one's going to need considerable overhaul on both channels. But yeah, it just got me. It just absolutely got, because it reminded me of. So yeah, it was proper. It was bent to shit. I managed to straighten it up, just hammering it between some pieces of wood and stuff. Yeah, it took me like a few minutes to get it undone. Just a little bit of patience, a little bit of intellect, something which I'm going to say they looked to be lacking in, and a little bit of the correct application of force rather than just trying to smash it open with Dave's DeWalt drill. And then they tried putting the wrong screws. There's like the big grub screws for the fan. They tried putting some of them back in the case, and they actually managed to get a warranty return on this thing with a case which had clearly been taken apart and pried open, the bag of screws which they took out and hadn't lost, and bits rattling around inside from where they've undone them. It just shows that some companies are so busy that when you do warranty claims, they don't even unbox what you send back. You could have literally just put something completely, you could have put bricks in the box, kept the working out, put bricks in the box, sent it back, and I'd have ended up with a box full of bricks. So yeah, that's, oh Jesus, bastard heavy. So yeah, they're not, they're by no means like some of the big ass amps I've had in, you know, like the old Cambridge Audio ones and stuff. But yeah, that was just reminding me of a little, I've had like people ask me about fixing car amps and stuff for them before, and they've come over with a bag full of bits, just a bag full of bits. You know, I'm looking at it, I'm like, what happened, mate? It's like, oh well, it stopped working, so me and my dad, or me and my mate. It's always me and someone. It's never I. It's always me and my mate. You know, me and my mate. We thought we'd have a look inside. You're like, fair dues. You're like, fair dues. If something's broken, 6 screws to take the back off. You've got the right tools, and you're not like knobhead who tried to undo that. Have a look inside. Even if there is something broken, when you take the top off and go, I have no idea what any of these things are in here or how they work, that's the point where you should say, I'm not going to go any further. But even if you didn't have any and you see these things are broken, it's the point where you still go, well, all right, I can see that's broken, but I don't know what it is. And, you know, even if these are blown, changing like these output transistors won't fix this amp. It'll just instantly go up in smoke again, because you've got to probe all the way through this board and go, do you call it upstream or downstream? Signal wise, it's upstream, because these are the final point. However, to me, because this is the point that's failed, although signal wise everything's upstream, to me it's all gone downstream. It's started here and it's gone along. It's avalanched along downwards. Yeah, off on a tangent there. So anyway, yeah. At what point, when you don't know what these bits are, you stop. But they've then took like the main board out of it, like all the clamps off the heat sinks and everything. Took that apart. There isn't the big red button or the big flashing light saying press here to fix, or a little arrow saying change this bit. And then they've took all the daughter boards out and everything and ended up with this whole thing full of bits that even if they had figured out how to fix, they clearly couldn't put back together again because they haven't put it back together. And they've come up to me and gone, can you do anything with that then, mate? And you know, my response has been, well, I can chuck it in the bin for you. They like laugh, like think you're joking. You're like, I'm not joking, mate. You're like, seriously, I'm like, it's no good to me like that. Like if you give me an amp in together, you're like, I don't even know where anything came from, mate. What screw came from where? So, oh, can't you do anything with it now? You're like, no, mate. You're like, I can chuck it in and be like, all that's good for me now is scavenging bits off of it. Down there I have a whole collection of bits and bobs, just boards pulled out of stuff that I just scavenge bits out of when I want. I often wonder what goes through people's minds. You know, that old little knowledge is a dangerous thing. Enough knowledge to have a go, but definitely not enough to know when to stop. Not to know I'm messing about something I don't understand here. I shouldn't be sticking my fingers in it. You know, kind of liking it. I mean, it's a different scenario altogether. It's kind of like your dog having an abscess, thinking, do you know what? I've read a medical book. I can operate on that. Cutting your dog open, it dying, and then taking it to the vet's wrapped up in a blanket and saying, can you fix my dog for me, mate? I've had to go fix it myself, but I couldn't. You know, it's oh, you know, how you learn. If you're gonna try and learn on stuff simple. I learned electronics by messing about. So you start simple and work your way up. You don't just try and take apart your 400 quid car amp after it blows up because you've tried running a load of 1 ohm subwoofers on it for some reason, or whatever the hell they've done here, and then not put it back together and expect someone else to fix it for you. It's like, no, if whatever it is you're taking apart, it's like going to the horses. A mate of mine always gives me a bit of advice, like with betting. He says, when you go to the horse, I'm not a betting man really, I've just gone like stag do's and stuff. So if you go betting, you've got to be prepared to walk out of there with none of the money you went in with. That money you're betting, you've got to be willing to lose it, and you've got to be okay with losing it. And this is where people go wrong, isn't it? They go in absolutely penniless. They're in there in the frigging betties every weekend, and they go in, and it's to the point being where they need to win. That money they can't lose. They already need 50 times more than the money they've gone in there with just to clear their debts, and they're adamant, this is the big weekend, this is the one I'm going to win back. And they lose that money and they can't afford to lose it, and it just spirals out of control. It's the same with having a go at fixing stuff. If you want to have a go at it and it's simple enough and you're not going to kill yourself, then have a go. But be prepared that when it goes up in smoke, you've broken it and no one else is going to be able to fix it for you because you've messed it up even more. But I'm just ranting now. I started off as a rather comical story about how the hell they managed to get a warranty return on an amplifier. They practically tried to crowbar open, and what was going on in their mind when they was trying to crowbar the fucking thing open. But so anyway, yeah, completely different. Some of these I plugged in, so I think I had 2 XGA5000s on that pallet, and they just, I've not actually hooked them up to anything, but they just seem to spark into life. Like so you have this one, because that amp board burned out and stopped drawing current before the supply fuse broke. With that amp plugged in, it was just coming up on protect mode because it was seeing a DC offset. Unplugged that amp, worked fine. Some of the other ones I've had today, again, just protect mode on, won't power up at all, blown fuse, you can rattle them here, stuff rattling around inside, so stuff's blown apart. But the two XGA5000 models, one of them, I opened it up out of the box and it was packaged that well. IEC lead still got the tie around it, the little bag it come in, didn't look like it had been open. The bag the amplifier was in didn't look like it had ever been opened. None of the packaging was destroyed at all. And it was almost as though someone had opened the box, like brought too many of them or something. Who knows? It's like they got the thing, opened the box and then gone, don't need that actually, and sent it back because it looked like it and yeah, just plugged it in and it's fired into life fine. The other one, always like when you try and take stuff out of boxes, see how people have it set, it gives you an idea of what it was they was trying to do. Well, the other one was in bridge mode, and I noticed on this one, I will confirm this in a later video, when you put it in bridge mode, normally, well, I'm way off there, look. So normally when you put amps in bridge mode, it's the left channel or the odd channel. So if you got like say a 2-channel amp, channel 1 is your input. So you put it in bridge, channel 1 would be your input, or your left channel would be your input, and then you come across your outputs. Well, this one, because the bridge circuitry and that will still separate. If you put it in bridge mode, you can still actually use the working amp, because you still got the negative connection there. You just not got your phase inverted output on your other signal, on your other output. But this one, putting it in bridge mode, it actually wanted the input in on channel 2, and instead of controlling it on the channel 1, which is what I'd normally be used to, it was actually controlling it on the channel 2 knob. And I'm just wondering if the other one of them is actually fine, but they've just tried to run it in bridge mode, have plugged channel 1 in, like gone, not working, send it back. So yeah, they're ones to get up and test at some point, but it's one at a time. This one's getting fixed first, that one's only there. I just had to bring it up here because I just wanted to see what the hell was going on inside it. And that is interesting now, seeing that it's blown both channels out. That suggests to me they've put a, like, shorted, tried to run like a load of speakers off it, is shorted them together or something. Who knows? They've done something to it. For both boards to blow like that, you know, bear in mind the only thing they share is a power supply. One can go and it won't affect the other. The only time one blown will affect the other is if the outputs are connected together through a load, and it would have to be a pretty low impedance load at that. So yeah, we shall see. But lots and lots of videos on testing these. I might modify some of them. I was thinking like some of them I might put some of my own innards in. I was thinking, you know, like just a whole array of transistors on one heatsink driver board. We'll jiggle some stuff around in here, like yeah, might make some driver boards to go on here, but several transistors, like really beef them up. Yeah, I've got options. I've got a pallet load of the things to play around with. Yeah, so that's Liam kept busy for quite some time. Oh yeah, the bits to fix this come to 20 quid, and that's including the fact I've had to buy like reels of some parts. Like, you know, you don't just buy one 100 ohm 1206 case resistor, you buy like 100 of them, like on a reel. And the same with the SOT33 transistors, the same with the, you know, I figure there's going to be some common parts that are dead between all the amps, so I brought them. The yeah, only things I didn't bulk buy were the output transistors on this. I just wanted to get one working first. And the price I paid for them, if I get one working and flog it, that pretty much covers the rest of them as well, which is quids in for me. So anyway, yeah, thanks for listening to me waffle on. I probably sounded a bit like an ass in my rant there, but who cares? It's my Friday. I'm allowed to feel like an ass if I want to. And that just came out wrong, didn't it? Feel like an ass if I want to. Be an ass if I want to. Who cares? So anyway, yeah, and if some of these aren't worth fixing, if like they're just shit inside, I can put my own innards in, or I can just salvage them for repairs, or wait a minute, who knows, whatever, innit? Whatever. So yeah, anyway, thanks for watching, and hopefully you can see a bit more now. I've got lots of extra LED lights in here, and I've been playing around some of these camera settings, figuring out how to use it a bit better. Yeah, anyway, catch you next time.